Hey everyone, today we are going to solve the LeetCode question isomorphic strings. Okay, simply each character of both strings should be pair, so that means their indices should be the same. To keep character and its index, we use two hashmap. So we have hashmap for S and T. And let's iterate through one by one. So we find E from S and we find A from T. And let's look at the hash map. So there's no data. So that's why just add E to hash map for S. So E is index 0, right? And add A to hash map for T. And A is index 0, right? Next, compare the indices of E and A. And they are same, so which is no problem. And then move next. We find G and we find D. And check if we have G in S. We have only E, right? So that's why G is a new word, new character. So that's why add G in S hashmap. So position is index 1. And on the other hand, so from T, we find D. And check if we have D in T hashmap, we have only A. So that means D is a new character. So that's why add D and the position is index 1. And then let's compare G and D. They are same index, right? So which is no problem. And then move next. Again, we find G and we find D. And check if we have G in S and we have G here, right? Index 1. And on the other hand, check if we have D in T hashmap and we have D, right? Index 1. So that's why in this case, so this position is index 2, right? But we already find G and D at index 1. So that's why compare, so 1 from S hashmap and index 1 from T hashmap. So they are same, right? So that means there is no problem. And then move next and move next. And we finish iteration. So we reach end of strings. So that's why in this case, all characters are fine. So we should return true in this case. Let's see false case quickly. I think you will understand the algorithm deeply. So what if the last characters are A and D? So let's see how it works. So in that case, A is a new character, right? There is no A in S hashmap. So add A to S hashmap. A is index 2. On the other hand, we find D again, right? We have D already. So that's why this time we don't add current D to T hashmap. Next, let's compare indices of A and D. So A is index 2 and D is index 1. So that means we already use D with other character. So let's see. So at index 1, we use D for Z, right? And this time, we use D for A. That's invalid, right? So that's why we should return false in this case. That is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create two characters. So one is, let's say, char index S equal hashmap. And let me copy this and T. And let's iterate through one by one for I in range and length of S. And if current character in S not in char index S, in the case, so let me copy this, we should add current character from S. So key should be current character S and I, and the value should be index, so I. And let me copy this, so we create the same for T. So that's why current character in T is not in char index T. In the case, the current character to hash map with current index. So let me change t here. And then if character index s and current character from s is not equal, and let me copy this, character index t, and the key should be current character from t. So if the indices are different, in the case we should return false. And if we reach the end of string, we should return true. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, where n is the length of input string. And the space complexity is, I think, O1. S and T consist of any valid ASCII character, so which is, I think, 128 characters. So that's why O1. So let's talk about solution 2. Okay, in solution 2, we use one hash map. We keep characters in S as a key and the characters in T as a value. So let's use these two strings. So first of all, we find E and A. So since we don't have any data in, so this is a character map. So just add E and A to hash map. So as I told you, character from S should be key. So E and the value is character from T, A. And then move next. We find G and D. So now we have some data in hash map, character map. So let's check. So do we have Z as a key in hash map? There's no Z, right? And do we have D as a value in char map? There's no D, right? So I'll explain why we check the values later. So anyway, so we don't have a D key and a D value in hash map. So that's why add D as a key and the value should be D. And then move next. Move next. And do we have Z as a key in char map? Yes, we have Z, right, as a key. So in that case, we compare D value, so that means D versus current character from T. I mean, this D. So if value from character map is not current character from T, in that case, we should return false immediately. But in this case, they are same, right? So that means no problem. And then, so now we have D as a key and D as a value. So we don't have to add these two characters because we already have in hash map. And then move next. And there's no character. We finish iteration, and all we have to do is just return true because we reach end of string. Okay, somebody is wondering why we check all values. So let's see this example quickly. So let's iterate through one by one without checking value. So first of all, we find E and A. So do we have E as a key? We don't have E, right? So that means E is a new character. So add E and the value is A. And we don't check values. So just move next and move next. Check if we have Z as a key in hash map. There's no Z, right? So that's why add Z and the value is D. And then move next and move next. And check if we have C in hash map. There's no C, right? So that's why C is a new character. So add C to hash map and the value should be D, right? So now we reach end of string. So in that case, we should return true. But it's wrong, right? Because D creates two pairs. Why this happened? So that's because we didn't check values. So let's check values. So let me delete the last pair here, and we go back to the last index like this. So when we find C and D, so do we have C as a key in hashmap? So we don't have C, right? So that's why seems like C is a new character. And then this time, let's check all values with D. So do we have D as a value in hashmap? Yes, we have D, right? That's why we are sure that we use D for like a multiple characters. So in this case, we use D for D and C, right? So that's invalid. So in this case, we can return false. That is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create a char map. So this is hash map. And then for S character and T character in zip and S and T. And if S character is in char map, so that means we have key. And check if character map key should be S character is not equal T character. In that case, we should return false. Oops. Else if, so that means we don't have S character as a key. So in that case, check all values with T character. So T character in char map dot values. So if we have a T character in a hash map, in that case, we should return false. If not the case, we should add current S character and T character. So char map key should be S character equal value should be T character. After that, we should return true. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, where n is the length of input string. And somebody wondering, how about the values? But I think it's an order of 128, which is 01, because S and T is consisted of ASCII character, right? So we have 128 ASCII character. So that's why this values doesn't affect time complexity. So overall time complexity should be order of n. So n is the length of input string. Yeah, I have one more idea. So as a bonus code. So let's see how it works. Okay, if number of unique characters are the same and the number of unique pairs are same, we can return true. So for example, so how can we calculate the number of unique characters? So to do that, we use set. So set and S should be E and Z, right? And set T. So this should be A and D. And we need one more, actually, set and zip S and T pair. So in this case, E and A and G and D. So why do we need set zip like this? So there is a case where number of unique characters are the same, but unique pairs are invalid. So let's see this example. So let me change string and like this, and S should be, let's say, BBA, and T should be ABA. And let me delete this, and this. So in this case, set S should be BA, and set T should be AB. So looks good, right? So we use B for A, and we use A for B. But let's think about the set zip. So pair should be B, A, and B, B, and A, A. We have three different pairs. And we use B for A, and we use B for B. So that's invalid, right? So if we check only set S and set T, so as I told you, looks good, right? So if we check only set T and set T, we will return true, right? But actually, this case is false. So that's why we need to set zip and create pairs. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. So return length of set S equal length of set T. And then equal length of set and zip. So we create a pair S and T. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n. So length set S is O(n). So n is the length of input string. So length set T is O(n), and the length set zip is also order of n. So 3n, so which is O(n). And the space complexity is, I think, also order of n. So because all pairs are unique, if all pairs are unique, set zip can contain a maximum of O(n) elements, right? So that's why. Yeah, so that's all I have for you today. Please support me with your actions such as comment and hitting like button. I'll see you in the next question.